All right, my name's Levi Scully, and I'm here to talk to you a little bit about accelerating VR research. We got to see the great Ivan Sutherland picture already, so I feel a little beat to the punch. But me, like a lot of you here, probably will admit that you think VR is the future, or at least has a pretty good spot in the future. And Ivan Sutherland would definitely agree with you. And I just want to read this quote that he has about VR because it is, I think, an excellent place to look towards moving to the future with. So the ultimate display would, of course, be a room with which a computer can control the existence of matter. A chair displayed in such a room would be good enough to sit in, handcuffs would be confining, and a bullet displayed in such a room would be fatal. With appropriate programming, such a display could literally be the wonderland into which Alice walked. So if we know VR is the future, how are we going to get there? I don't know if you're like me, but this is most of my days as a VR dev. Overwhelmed, sad, and have no idea where to go for it in the future. So with the advancements in VR, development just keeps getting more and more complicated every day. These new tools and new software approaches like AI are incredible tools for VR, but they're just increasing this complexity after every new innovation. So with all of this added complexity, how do we get to the future? Well, I do know that if we just keep going, we'll get there, but we might not get to where we want to. So whenever I'm looking for guidance, I look towards several people, but Adam Savage is one of them. And he has a book called Every Tool is a Hammer. And in that book, he talks a little bit about his shop philosophy. And this is a externalization of a philosophy of how to work. And that philosophy comes from the people in the shop and those maintaining it. So for Adam Savage, this comes down to two basic principles: visual cacophony and first-order retrievability. So you can see in the picture here, it's a very messy-looking environment. But for Adam Savage, he wants to be able to look around and see any solution that he can to a problem without having to open cabinets or look into drawers and stuff like that. He also follows a thing called first-order retrievability, which isn't illustrated in this picture, but is essentially, if he's working on a thing and he often needs a screwdriver at that location, he's going to store a screwdriver at that location. And these principles work towards his shop philosophy goal, which is to create an environment with the lowest barrier to the flow state with protections to falling out of the flow state. So after I got guidance from Adam, I sat down and decided how I wanted to approach research. And I decided that I wanted to create an environment with the lowest barrier to experimental research, with the support and infrastructure to accelerate and simplify HCI experimentation. So to start off, we have one of my principles, which is magic or not, a wizard is always the most prepared person in the room. And to be the most prepared person in the room, I made ScryVR, which is essentially a template for running HCI user studies. It's broken up into 4 primary systems: the user study system, which controls custom Unity events, as well as managing the randomization and balancing of task presentation. We have some custom events, such as simple event timers, a object movement event, where if you move an object in VR over a certain threshold or rotate it, it creates an event. And then the object raycast can either be set on the participant's head or the controllers, and this kind of gets us a good idea of where they're looking at or what they're gesturing at with their hands. We also have the announcement system, which is used to present text and audio. a good system to just give instructions to participants as you're going through their study. And then lastly, a questionnaire system, which imports hard-coded questions, which you can also program your own questions for the system as well, and they will be pulled in. It currently includes the Player Enjoyment Needs and Satisfaction Survey, as well as the IP Group Presence Questionnaire. So just to break this down a little bit more for you, these are some of the inspector pictures from the system. You can see, if you can, they're just some samples of the different systems. In the, let's see, right here, actually I don't know where my mouse is, I'm not going to gesture. So there's just some examples of how the inspectors work and how you're able to utilize them through the Unity game engine. This is the actual access point to attach the game object to your event system. So whatever you're developing in order to test, you just attach these events to the objects there. This example is of the user study to validate this software. And the goals in it are to eat planets and to eat certain different planets. And so you can see here, the on planets eaten, on Jupiter eaten, that's all tied into the trial and the event system to be able to drive everything along for you. So if you can program an event, you can have the system tie in and it'll drive everything for you. The survey system, this is just a quick example of what it looks like. This is on a PC screenshot, but it can be used in AR or VR just as easily. And there's just a hard code example of how the questions are coded. This is just a quick little animation of the video, or the questionnaire system kind of going through the questions for you. All right, so besides being the most prepared person in the room, I also try to have the most fun. So in order to validate my software, I used this user study to replicate it. And the user study that I was trying to do is getting somebody engaged in a task and then asking them questions in VR, in AR, or on a PC, and seeing how their responses to those questions depend based on the media that they're participating in. So we have two levels of immersion, a fully augmented reality and a fully virtual reality, with questionnaires inside AR or VR and outside on a PC. So that is the virtual environment, or outside of the virtual environment would be, our reality. Then I had a couple of research questions to try to answer using the template. This is a device called the Emotibit. It gathers very basic peripheral biomarkers. And what we wanted to see is if there was any impact of immersion on their physiological responses. We also wanted to see their usability and comfort level in VR and in AR. So we gave them 5 different tasks. We have them eat planets, eat as many planets as you can in 2 minutes. You have to eat Jupiter as fast as you can, and then you answer the questionnaires. And then by doing this, I was able to get some interesting results. However, there was a lot of issues on the SQL side of things. It turns out when you're building a template with multiple systems, things get complicated quick. So this is really a very simple observation. You can see in blue is augmented reality on the sort of crab-shaped data, and it's the opposite on the other side of the screen. But this just illustrates pretty well that people move around more when they're immersed than they are when they're comfortable in their environment. Because the blue is the augmented reality, and they actually moved less away from their starting zone than the people who participated in virtual reality. And then the chart on the other side is the amount of movement, so how much they move their arms or their heads during the session instead of their physical location. So just seeing that, we can get a pretty good idea that people who are immersed will engage more in the concepts, which seems obvious, but here we have the data to back that up. So after all of that is said and done, what is going to be next for ScryVR? So there's definitely a lot of room to integrate other systems in. I like often saying that we're not program engineers, we're software engineers. We work on systems, not individual things. So I need to go back to my full stack history and work on some integration for the creation wizard for this. Unity was just not robust enough to be able to handle everything that I was throwing at it. I do definitely also need to add better error reporting. There were some issues with lags where data was unsynced from the database, and a lot of our participant trials disappeared because of that. We need some more robust testing because, again, losing data is very painful, and nobody ever wants to see that happen, especially when you're relying on a system to help you out with those problems. Another thing I want to do is test it beyond the Quest line. I'd like to try it on a more PC VR solution, maybe just Steam VR or something like that. I want to use this template to help more people at my university conduct VR research. And hopefully other universities, if I can get that shopped around. But before I can do any of that, I need to get the documentation written. So, yeah. But to return to one of the questions, how do we get to the future? Just a day at a time. I just recommend to stop and think about our research and what we need to support it before we start developing headfirst. All right, thank you very much.